Oh yeah, I think we can start.
Hi, sir. This is Sunny.
Yeah, go ahead.
Sir, I have a question, sir. Can I share my screen? Just I wanted to ask.
Yeah, sure.
Okay. So please allow me to share screen.
Yeah. Okay, you can share.
So is it visible?
Yeah, it's visible now.
Okay. So, sir, I was testing with Leanet,
Mm-hmm.
and these are the scores and different, different. I
Yes.
have tried this 10H
Okay.
versus average and number of epochs.
Mm-hmm.
So I have got this score like maximum is with Relu max activation sorry max
Okay.
pooling and 100 epochs. So I have got the max accuracy here, but I have
Okay.
tested with others also, so it is quite close. So in this case,
Hmm.
what we should choose means, is it okay we can choose others as well, or
So
it's
you have chosen which network? Linear, just linear, right?
just Leanet? I was testing with Leanet with
Hmm.
different activation function and different max pooling or average pooling, and
Hmm.
then number of epochs. So this, if you see the last one, that is Relu max and 100 epochs. So
Hmm.
that's how the naming convention. So
Okay.
I've got test accuracy 99% here, and I'm testing
Okay.
it was only on the MNIST dataset.
Okay.
So in
Okay.
this scenario, that which should I?
Yeah, so in that case, you can choose this one itself, Linear. But the thing is, like, Linear is a basic network, right? So, if
I just wanted to understand the differences, like with the
yeah,
richness,
in
like
that
you said.
case, fine, you can make a decision. Yeah, so like
Okay.
this one
Mhm.
for sure. So like you always go after the accuracy. So
Mhm.
yes, that will be the answer in that case.
Okay, okay.
Yeah,
Okay, that's
yeah,
all for
great
now.
work. Yes, yeah,
Thanks.
thank you.
Okay.
Sudhanshu, actually, real time, how do we select the algorithms, which is the best algorithm for my data set? Because
We'll
there
talk
are
about
multiple
it. I think I've given you some kind of a description in the class, but even going forward, so I'll talk about it.
for
Yeah,
classification as well.
yeah, yes,
Sudhanshu, Harish here.
yeah. Go ahead,
Uh,
please.
I have a small clarification on deep learning, what you have mentioned on neural network architecture.
Mm-hmm.
You have mentioned about during a forward propagation, the weight going to be initialized randomly, right?
Yes, yeah.
Uh,
Sometimes. So we
yeah,
try
what
to
is
take
the,
a
yeah,
predefined weight, and sometime we are going to take a random weights. That is true.
random means there is surely some math behind it, right? Can you
So
explain that?
random means, have you heard about the np dot rand function, rand end function, rand end function?
Yeah, yes.
Yeah. So those kind of generally weights we used to assign. So basically, it will be a random normalized data set that we used to pick and choose, and then that we used to define that as a weight.
Yeah, okay. I have another clarification.
Mm-hmm.
Uh, we have a count vectorizer, right? Count vectorizer, DFIDF vectorizer.
Yes.
In that, we have a method called fit transform and transform.
Hmm.
What is
Fit
the
and
major?
transform, generally fit has been used for, I would say, a learning purpose in general, the way library has been designed. So this is basically a method you will be able to encounter in library. So wherever we have to learn something, so in general people have named that as a fit, and wherever we have to do just some kind of a transformation, so there it will like a name as a transform. That's the only differences based on the naming convention that people have followed.
Okay. Then we have a method called transform, right?
So transform also and fit transform also, so it's almost like a similar, I would say, difference library by library. There is not such differences you will be able to find, not much differences you will be able to find out in between in general. Yeah.
Sorry, your voice is not clear to me. Can you repeat?
No, I'm saying that there will not much differences you will be able to find out in between in general. So it's basically a naming convention, right? Suppose if I have designed the library, right? So basically it will be my wish that what is the name that I'm going to keep, right?
Yeah, okay.
Yeah, so basically it depends upon me and you. So I used to keep my own name. So in a similar way, so people who have designed the library, or the group that who has designed the library, because all of those libraries are basically open source libraries, right? So based on like a convention, so they used to keep fit transform, or a fit just a transform. But in general, naming convention is like wherever we have to do some kind of a learning in general. Again, I'm saying in general, somewhere even you will be able to find out that we are not learning something, and then even we have kept the name as a fit. Okay, so in general, so it's just a naming convention. So basically, it's my library, right? So I can choose like what name I can give in general. Yeah.
Yeah, okay. I got your point. Thank you.
Yeah.
Sudhanshu, actually,
Yeah.
we use flow from directory to read the images stored locally, right?
In
So
general, yes.
yeah, so there we pass data augmentation parameters. So I did not find any parameter which says that from one image generated 20 image or 30 images like that. So how it generally works in internal?
I think in one of the example which I have shared with you, so in that one data augmentation method we have already given you, right, Paul?
Yes, yes, yes.
In
But
which one? So
internally, Keras handles that. Okay, you don't know how many images it will produce, like 20 or 30. That's an internal matter. Okay, that's why
Okay.
you
so
can't
yeah,
know that.
but
It's a
even
random thing.
we have already given, we have already
Yes,
mentioned
yes. We have
our
given
own
a
method,
lot
right?
of methods, basically augmentation methods. We have
Yeah,
given.
so we have already given our own method as well. So one thing has been done like it's been handled by Keras and library itself, I would say. So again, Keras is a high-level API, so it sits on top of TensorFlow. So that is one thing. So it like try to generate it, and we don't know, we are not aware about that how many images they are going to produce in general. So based
Yes.
on some normalization method, so they try to produce the number of images. But there is another method which I think in some of the example, I'm not sure. Basically, maybe into a PGG or maybe into an inception net.
In the
Uh,
ResNet, it is there. Get random erasing. It's based on a research
yes,
paper.
yeah. So that is already there. So we have already mentioned that method, so that you will be able to generate your number of the images, and then you will be having an idea that okay, fine. So you can control the number of the images there. So it's not be like it won't be like just you will not know that how many images it is going to produce. So in that case, yes, you will.
Okay. Okay. Thank you.
So you can use the default one, or else you can use your own. So both way is possible, and both way we have given you. Yeah, going forward, I think in object direction, in almost every example, we are going to use it because for sure, whenever you will collect the images, so we will look for always like 1,000, 2,000, 3,000 images for one single object, and you won't be having that much of object, and to create the mixture of that, so we are going to use these kind of a method in almost like every example that we are going
Thank
to
you.
build. Yeah. Okay.
Hi, Sudhanshu, Vivek here.
Yeah, Vivek.
Sudhanshu, I was trying with Inception V3 as Cipher 10 dataset.
Okay.
So in that, the Cipher dataset having a 32 into 32 into 3 shape, right?
Yeah.
So how we can decide that when we are trying to validate any image, so we are again setting into 32 into 32, right?
No, input could be anything, right? It's not like we are going to set 32 cross 32. See, there is something called as a benchmarking, right? So if like when suppose if I have developed some network, again in Inception, so we have seen that there was an Inception V1, there was an Inception V2, there was an Inception V3, then there was an Inception ResNet, V2 model was also there. And apart from that, there are many variants of the inceptions that we have seen now. So it depends upon me, like what is the benchmarking. So what is the image dimension which I'm going to use? So if people have taken standard images, that is fine, but it's not like I can't take my own images with a different dimension. It's completely fine. Dimension, input dimension wise, no one is going to tell you that okay, so always try to take only these much of dimension.
Yeah. So Sudhanshu, can I share my screen so that I can show you where I'm?
Yeah, go ahead. Sure, you can share. Yeah.
So is it visible?
No, not yet. Have you shared your screen, Vivek?
Yeah, Sudhanshu. Just
no,
a
I'm
moment.
not able to see your screen.
Oh no, not yet. Sorry.
Now it's visible. Yes.
Is it visible now?
Yeah, it's visible now.
Okay. So Sudhanshu, here we are setting up the target input shape as 200 into 200 into some random shape,
Okay.
right?
Yeah, that is fine.
So after that,
And ImageNet weight you have taken, right?
yeah, ImageNet weight, yeah,
So
exactly.
you have taken the weight of 1000 classes is completely fine. So again, you are, and again, what is the next data set that you are trying to take?
C for 10.
C for 10. So see, again, so like you will be able to understand this part. So many people even gets confused, right? So in ImageNet, how much number, what is the number of the classes?
1000.
1000, right? And what
Yeah.
you have done, so you have taken the weight. Weight you have taken means you have taken the predefined weight.
Predefined weight, yeah.
Right? And predefined weight from the different classes. So again, that is possible because whenever we say like we have taken the weight, it means what? So can I say that there was all the convolution layer and there was a feed forward network. So we have taken only a all the weights for only for the convolution layer.
Yeah.
Right?
Yeah.
Only for the convolution layer, fine. And then you are trying to train these things for the 10. So fine. So you are trying to modify your final layer in that case.
Yeah. And so after that, here I'm trying to validate my shape, like which category it belong to, right?
Mm-hmm.
So here when I tried with 128 into 128, it was throwing error. So I have.
So see what happens is, so whenever you have trained your model, right?
Yeah. Yeah.
So you have trained your model, and at that point of a time, training. Suppose okay, forget about image, right? So have you built any machine learning model? Must be you must have built a model into linear regression or logistic regression, right? Yeah, as a beginner sometime back. Yeah. So whenever we try to train our suppose linear regression model, right? So suppose if I have taken maybe x1, x2, x3, x4, x5 as a feature, right? So can I say at the time of training, so can I say that we try to give a similar like amount of a feature value at the time of testing as well?
Okay, got it.
Got my point? So you have taken some shape of the, because see what happens over here. So finally it will go through all the convolution layer, whatever you have done with the training images, right? It will do with the test images as well. And then, so finally it will get into a feed forward network, and then finally it will give you some kind of a classes. Okay. So to follow that particular approach, so for sure, can I say that it is going to need a similar, like a dimension of array?
Yeah.
And matrices, right? So that's the reason. So whenever you're talking about a testing, so in testing you are always supposed to give a shape of the images which is equivalent to your training. Okay. If you will not give, for sure it is going to give you an issue. So make sure that training and testing image size should always be same. If it is not same, so there is no way that you will be able to get the final result, because we always try to talk about the feature dimension should always same.
Yeah, got it.
Feature dimension should always be same, right?
Exactly.
And same thing we used to follow.
One more thing, Sudhanshu. Suppose here we are using ImageNet weight, right? Sometimes we are using like if layers of inception layer layers.trainable equal to false. Means we don't want to train any weight. Whatever weight is there, we are going to use that.
So when we say we don't want to train any weight, so sometime we talk about only a convolution layer. So see, there are 4 to 5 kind of a transfer learning. So I will be talking about in your next classes. Okay. So transfer learning means what? Transfer learning means, see, I have a network, and then maybe that network is having already a well-known weights. Now, what is the meaning of well-known weights? Well-known weights means I will be able to recognize some kind of a shape, some kind of a sizes, some kind of a edges, I would say, or some kind of a density or some kind of a color. That is the meaning of weight in general. Means I can understand some kind of relations. Now let's suppose, so I have just for the layman example, because as of now I think I didn't talk about a transfer learning in your class. Right? Next class I will talk about. So based on the assumptions that we have discussed so far so good. So see what happens is, suppose you have taken an ImageNet weight. Now can I say that in ImageNet there was 1,000 classes, right? So my model will be able to understand all those 1,000 classes. Suppose a bag and then matchboxes or maybe a square shape kind of object, it will be able to understand, right? Now if you have taken the new image, right? Suppose you have taken the new image. Suppose you are trying to train all of those images with your purse. You know purse, right? Purse, like wallet.
Wallet.
So I said that like you have taken already a weight in which it will be able to identify all the square shape, linear shape, and all those things. And now you have taken a wallet. Now can I say that even in the wallet, so you will be able to get a similar kind of a feature? to define the wallet.
Yeah.
So in that case, what happens is, so I already know that, okay, fine. So in my previous ImageNet weight, so these features was captured, right? Now if I'll try to take all of those features, right, at least, so it will be able to learn quickly because I don't have to train the entire weights in that case. But let's suppose you have taken the ImageNet weight, which can understand all the edges, all the square shape and all those things, right? But now you have taken what? You have taken an image of cat. Now, can I say that cat image will not be flat, or cat image or cat pictures cat pattern will not be a square? It will be having some kind of a zigzag pattern, right? Now, in that case, can I say that if I'll try to take this, I would say ImageNet, so maybe it will not be able to identify it will be able to identify certain property, but it will not be able to identify much of the properties. So can I say that in that case, maybe that weight will not work? Maybe I should take some other weights where people have trained like a data set with a similar kind of images, similar kind of a shape. Right? So basically in transfer learning, so it's not only a single approach that we used to follow in transfer learning. So we try to follow 4 to 5 approach. So sometime what happens is, sometime we try to take the entire network, sometime we try to change just a forward connected layer, sometime we try to change in between some layer of the convolution, sometime we try to take a weight of the entire layer, but we try to train from the very beginning. So it depends actually. So it depends like what kind of a weight that is available that we have taken, and what kind of a data set now we are trying to provide a new data set based on that my model is supposed to train itself.
Okay.
Right. So it depends. So 4 to 5 kind of a transfer learning is there, and hopefully I will be talking about that maybe in your next Saturday or Sunday's class, because last time we talked about a inception net, right, on Sunday's class. So hopefully, so transfer learning, and then I think you will be very much clear on that particular level. But yes, just as a layman explanation, so I have just given you some thoughts.
Okay. Thank you.
Yeah.
Hello. Hi. This is Aman Sharma.
Yeah. Go ahead.
So we've talked about convolution CNN, right? So my question is, was
your
that
batch, Aman? Is it DLCVNLP or DL?
Sorry?
Your batch, Aman? What is your batch? Which is your batch? DLCVNLP or just DL?
Just DL.
Okay, DL. Okay, fine then. Yeah, go ahead.
So my question is that we've talked about CNN, right? So was it 2D CNN or 3D CNN? Because I come across something known as 3D CNN, and I wanted to know that how does that work?
Okay, Aman. So as of now, whatever network that you were creating, so whether you have taken a CNN 2D network or CNN 3D network?
I think it's 2D.
2D, right? So yes, it's 2D.
So what is CNN 3D? Like I think I was doing some problem searching for preserving some spatial features. So is it useful? Like I wanted to know more about it.
Sorry, what was useful?
The 3D one, the 3D CNN network.
3D CNN network is also useful. 2D is also useful. The only difference is that you will be able to find out in between is like in 3D. So we always try to take, or we always try to, I would say, give 3D images going forward sequentially. So depends. I will tell you one thing over here.
Okay.
So what happens in general is, let's try to focus on this picture. I think I have drawn this picture even last time. So in your class. So generally what happens is, suppose we have taken a image over here. Suppose I have taken the, suppose if I have taken a image, and again, so basically I have an image in this particular way. I have an image, and then so I'm trying to apply basically a filter on top of that one. Yeah. And again, this filter is 3D. So can I say that whenever I will try to apply a filter on top of this one, right? This 3D filter, if we are trying to apply, right? So this is one filter. In general, what happens is, so we try to take 3x3 filter, 5x5 filter, 7x7 filter, 11x11 filter, right? So it generally try to apply over here in this particular place, and again, so in depth, so it try to apply the same amount.
Complete.
Right? In there means the same multiplication we are trying to do, and then we are trying to do the multiplicative addition operation. This is what we have discussed, right?
Yes.
Now, if we are trying to talk about this kind of filter, if we are talking about the 3D filter over here, right? So now what happens? Suppose this is 3x3x3 in this case, right? So now what happens is, so not only we are trying to apply a filters in terms of a height and width, so we are trying to apply this filter even in terms of a Depth.
Depth.
Getting my point? So let's suppose this is 3 cross 3 cross 3 means depth of this one is 3. Now this is basically the original image size is basically like let's suppose a 128 cross 128 cross 3, right? So in depth, so it will try to do 1 to 1. So here what happens is there will be a multiplication of suppose this element with, I can say, so there will be a multiplication of, let's suppose, this element with this one, 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 with this one. Agree?
Yeah.
In dense depth, right? Yeah. But here in this case, what happens is so like here, so is basically a 3D filter. So for sure we are having a values even over here and even over here, right?
Yeah.
So it will try to multiply in this way. So that's the only differences that you will be able to find out in case of a 3D and in case of a 2D. So yes, in case of a 3D, you will be able to say that you will be able to extract a better features, right? Because here, so what you are trying to do is, so in terms of a depth, you don't have any variations. You're just trying to multiply with the same number. Means I have created one filter over here, right? And in terms of a depth, I'm not trying to make any kind of variation. Just based on this variation, the flat variation or 2D variations that we have, based on that, we are trying to filter the data over here. But here in 3D, can I say that there could be a variation? This number could be different.
Will be striding through the depth
Right.
as well. So
will be striding through the depth as well, right? So yes, it depends, I would say. So like here, so it will try to learn basically a 3D kernels, and then based on that, it will try to filter out. That's the only differences you will be able to find out in between 2D and the 3D that you are going to use. Apart from that, nothing changes. Everything
is this image a temporal one, like a sequence of image, or is it just a single image of RGB?
No, I'm talking about single images, right? I have taken 120 cross 120 cross 3. So I'm talking about the single image itself. 3 channel means RGB channel basically, right? And I'm talking about here basically like a single filter, 3 cross 3 cross 3 filter. But here, so 3 cross 3 cross 3 filter means what? So even in terms of depth we have something. But here, if I write 3 cross 3 cross 3, or generally we don't write in this way. We write 3 cross 3 cross 3. Now, what is the meaning of this over here? So 3 cross 3 cross 3 means 3D tensors or 3D, I can say filters we are talking about, right? 3D tensor or 3D array we are talking about. But here when we say 3 cross 3 cross 3, so can I say that I'm talking about the isolated, or I'm talking about the exactly 3 different kind of filter which will be responsible for extracting a 3 different feature out of my data? Right? So in case of a 2D, this meaning is different. In case of a 3D, this meaning is different. So here 3 cross 3 means only one. Here 3 cross 3, 3 different filters.
3 cross 3.
Right? So 3 different filters of 3 cross 3. This is what I'm talking about in this one. Is it making sense? Yeah. So that's the difference you will be able to find out between 3D and 2D. Apart from that, so there is no such differences. Multiplication, division, whatever we used to do in between, exactly same. Yeah.
So will we be covering this in the course module?
I think no. See, what happens is that's the reason last time what I have done. So I was in between a class itself, I think for 15-20 minutes. So I have drawn the diagram in much better way, and then I have shown the multiplication. That is how parameter multiplication happens in general, and this is the number of the parameter that you are going to get. Now it depends. Like I'm going to, so it's part of a library. So you can instead of going to pick and choose like a convolution 2D, you can try to go and choose 3D. It's completely fine. You can try to do the experiments, because I think if we know that what is the difference between 3D and 2D, then for sure it will be very much easy for you to implement anything, right? So you can experiment. Same data set, everything is going to same. Just try to change your convolution selection. That's it.
Yeah, sure. Thank you very much.
Yeah, and let me know about the result. Like people are showing me the result, right? So it's very good, like to see like people are spending a lots of time, and see like many of you have already done the benchmarking of a single model, like I have asked you in a class, right? So like do the benchmarking, and many of you have done that. Many of you have even sent me a mail saying that okay, fine, so this is the result which I'm able to achieve, and yes, this is what I'm looking for actually, because when you do all those things by yourself, like all the like a kind of experiments, and you try to test it with a different hypermeter, and now like a person who was trying to show the first like example in which he was able to get, had just experimented with the linet, and he was able to get a highest accuracy with a ReLU, right?
Yeah.
If I'm right. So with the ReLU and the ReLU max with the 100 epochs basically. So again, yeah. So this is the kind of outcome I'm looking for from the people. So just try to do the experiment with the 3D. So far so good we have done with the 2D. Just change that particular layer, right?
Sure.
Let me know. You won't face any issue, hopefully. Yeah.
Sure. Thank you. Thank you very much.
Thank you, Sharad here.
Yeah, go ahead.
I would like to share my screen.
Okay.
I was implementing VGG16 through Python, and it is giving me some.
Okay, Sharad. Yeah, go ahead, please. Yeah, Sharad. Are you able? Okay, fine.
Yeah. So when I am calling this predict thing, this model is equal to load model my model.h5. This is my VGG 16 model. So this is giving me this error. Unexpected keyword argument passed to optimizer learning rate, but I haven't passed anything. My screen is visible.
Okay, so just in prediction, you are getting this issue. So unexpected keyword argument passed to the optimizer learning rate. Go to the learning rate optimizer. Go to the place where you have defined your optimizer.
I have already. I had saved this model.
Are you talking about a Docker classification?
Pardon?
No, which example you're talking about? So just show me like where you have defined your learning rate and optimizer. So just show me the optimizer. Somewhere you must have defined the optimizer, right? So just show me that place. No, everything is commented. No, not here, not here. Data generation, yeah, here. So optimizer is equal to SGD you have defined over here, and then like unexpected this one model.compile model.optimizer.sgd. Yes, a similar kind of a issue I think even we were facing. Right, Paul, can you please ping a code, Paul, for like a SGD or some other optimizer, Adam optimizer?
I need to go through his code. It's something like for prediction, you actually don't need so much of code for training. Both of the files should be different. And he's keeping everything in one place. So I need to have a better look on this one.
Basically, this is the same code which was there in Jupyter.
Yeah, it is working fine over here, right?
Yeah, it is working fine over here. It is giving me the prediction here, but when I am calling it from PyCharm, it is giving me issues.
Because for prediction, it's not related to your learning rate. Learning rate comes in.
Yes, exactly. For predictions, we don't even give a learning rate basically. And here it is showing you that unexpected keyword argument passed to the optimizer learning rate. So for predictions, we don't even need a learning rate. For the training purpose only, we need a learning rate. Can you please go up a little bit? I wanted to check. Like,
I haven't called this optimizer while I ran this file on Jupyter, and then my model.h5 is created for my VGG16. Okay. Now I am not using this file anymore. From this client app, I have used it for a UI interface. When from there, it is calling this model to predict. This is the same file from
Okay, I got it. Say, open your predict.py once. Okay, now your prediction go above. Yeah, model.load h5. Just okay, this is fine. This is fine. Go below. Go below. Go below.
When I debug this line, you give me this error.
Okay, at that line the error comes.
Yeah.
Okay, during the loading of the model. Okay.
The same model is working fine in Jupyter. I have already created the model, and when I am doing this prediction part in Notebook, it is working fine. This is the prediction part. I am giving it an image and this is working. But the same code is not working in PyCharm.
Okay, show me your import once again. So load model import. That is fine. And load model, and then like you have given my model.h5, and your directory is fine, right?
Yeah.
So you are trying to keep all of your my model.h5 over here inside the same directory structure.
Yeah, this is the
CNN,
folder.
BGG.
These are the data.
देखा जा सकता है.
These are the
Okay.
images.
Can you please show me the prediction in your notebook, Jupyter notebook? So wherever like just
पूछ के बंद कर दे.
without using anything.
Yeah. I have already created this model, and here I am doing this prediction.
देखा था पूरा.
The same code which was there.
Just do a dir. No, dir and then like okay, PWD. Sorry, PWD bracket.
PWD is not working.
PWD
It works. Exclamatory.
Deep learning. No, the location which you from where you are taking this model and the location from where.
Yeah, but I have copied it at this location also.
Is there, right?
Yeah. This is the location, and this is already model and data set. Both are copied in the same directory as well.
Okay, and size of your image is same?
Size, yes. While calling,
so you have taken 24 for 224.
Yeah. It was giving me error because of the difference of the sizes. But later on, when I changed, here 224, so it was working fine in Jupyter. So same code I posted it.
You can execute it again. So just close everything. Just execute this part. I wanted to see again. Just a prediction part. Simple. Just a prediction part.
So in PyCharm, can I in this prediction part only?
Yeah. In PyCharm, just no need to train a model. Simple. Leave it. So just prediction part.
So I need to hardcode the path of the file here, no?
Yeah.
See, always before binding everything into classes, always check that your normal open code is working or not. If it is not working, then try to fix that and then try to bind within classes.
I have checked it here only. That everything was
everything is fine here. Fine. Not a problem. Same. Just do one thing. Try to put the same image in that case. So put the same image and let's see. Just pass image equal to self. You have passed, right? So just give the same name. So not a problem. Okay.
Now I need to run this only.
Yes. Yeah. Just call this function. So let's see what happens.
Okay. Sorry. These are the future warning.
So is equal to 0, right? So it's fine then.
You need to create an object of the class and then you need to call.
Yeah.
I need to create an object there. Okay. So I need to create an instance of doccat and then I should call this.
Yeah. Then call the function.
Yeah. That's right. This is equal to doccat and doccat dot dc dot this one predict doccat. Save and execute.
You have to remove that self.file name.
Number 36.
Can I pass this?
Actually, your constructor you can remove for now. Just comment it.
Okay. Should I run now?
Yeah. Show your error log, go above a little bit. Okay, wait. Okay, during loading of the model only it is having the problem. Okay, scroll down till then, no problem. Because in loading the model only, here the problem is.
Yeah, so just try to give one thing. There is whenever you're trying to load the model, right? So try to pass one argument called as compile is equal to false in that case. So here you're loading a H5 model, right? So in the same line, so just comma and then compile is equal to false. Yeah, compile is equal to false. Save it and execute it. Now error has changed, right?
And now I think it works. You need to install Pillow.
Yeah, so now it's working. So just try to install a Pillow. It will work. Done.
Pillow is pip install Pillow.
Yes, simple.
Yes, pip install Pillow.
Okay. Yeah, now it's working. So
and another thing is in this model, when I was running with 10 epoch, in the 10th epoch, it is saying that it hasn't ran the 10th one and saying that it did not improve from this accuracy will not improve.
So what is the thing that you have written in your code, training code? I wanted to see that. Training creators, okay, fine. Go up.
This is the same code which was there in Code Collab.
Yeah, because that line is printed because there it is specifically mentioned that best true.
Yeah,
just
best
go
true.
below. Just go below. It will always save the best weight. For example, if you are training for 10 epochs, okay, and if the best loss comes in the fifth, so it will always save the fifth one, and it
So
will
see in a checkpointing, so we have already mentioned save best only is equal to true, right?
Okay.
Checkpointing line. So below the epoch line, so we have mentioned
That's
save best is equal to true, and that's the reason. So automatically it will try to like take the best one, and that's the reason. So you are getting that message.
In this prediction also, two of the values for backpack and glass it is predicting fine, and for footwear and watch it is repeating the backpack and footwear. So this is
The
because
way
the
you
test
have
set
defined your directory structure and the way you have given this array, so maybe because based on that.
directory structure is simple, test and train, and it is the same how it was there.
Footwear, glass, in that case, should work. I think you should test it with this one. It should work.
So I should try it with more epochs, then it will. It should work.
Yes, you can do that. Maybe try this out, improvise it. It should work. What I assume is like it should work for sure.
Okay.
Yeah.
Okay. Yeah. And one thing is, what is overfitting? Overfitting of the image.
Overfitting simply means that whenever your training test accuracy is like lesser than your training accuracy, or that is called as a overfitting instance. So suppose if I have trained the model and then at the time of training, so it was giving me a better training loss, but testing loss was like very poor, right? Suppose training loss was 80% and then like the 20% losses I was able to get, but maybe at the time of testing, so I was able to get more number of loss, maybe 30%, 40%. There is a huge difference in between because we always try to print a training loss and train loss, right? So test loss and train loss. And if our test loss and train loss is equivalent, so in that case, we say that, okay, fine, my model is a balanced one. So if that is not a circumstances, in that case, we can say that my model is overfitted in this case.
Okay. Yeah. Thank you.
Yeah.
Hello.
Yes, go ahead.
Hello.
Yeah.
Yeah, hi. Sudhanshu, this is Vikash.
Yeah, Vikas, go ahead.
Actually, I am not so much comfortable in deep learning and NLP because I have just joined the class. So,
yeah, it's fine. DLCP NLP, right?
Yeah. So
it will take another 2 months of time for you.
Yes. So that's why I'm not plunging myself into the code right away. So I'm waiting for the step by step as you are already going through it very nicely.
Yeah.
So since I'm already working with the machine learning and stuff in my company, so I have a question. Let's say I am doing any a regression thing or a classification machine learning problem, and I have done some sort of standardization before creating the model. Fine. And after the standardization of my training data set, I have created my model and it's fine. I have pickled it in the, I mean, I have serialized that model.
Fine, I can understand
Fine.
all those words.
Yeah. And while executing it as a web service or any platform, if user is supposed to give the input, then user can't give the input in the standardized form. They will give the real life input.
Exactly,
So if I reload the model, then what I have to do to
so basically, okay, have you attended a machine learning class? Have you done any of the project in machine learning?
Yes, in my organization, I'm used to do logistic regression with
from our side.
No, never.
Then that's a valid question. I think you can ask.
Okay.
In our class, we all used to handle these things and we used to showcase in every project. See what happens is, so it will try to stand. So whatever pipeline we have built, even if you'll ask the people who had joined a machine learning and who has done a project into machine learning, so you will be able to see that we used to create a pipeline, right? So whatever pipeline we used to follow to prepare a data set till a model training, right? In terms of training a model, so we try to follow the same pipeline. So whatever normalization, whatever standardization, whatever transformation, whatever encoding that we used to perform on a training data set, similar exact same thing we used to perform even on a testing data set. So that dimension, dimension features, everything will be same when it will go for the prediction. So if you have a standardized data set, then for sure you should follow the same pipeline at the time of testing. So training and testing pipeline should always be the same. The only thing is at the time of training, so you try to learn. At the time of testing, it will just load the predefined model, like pickle file as you are saying, pickle or SAV file or whatever other files you will load and then do the prediction. But yes, you should do a standardization or encoding or normalization or transformations even at the time of testing, and similar kind of a thing you have to do, the thing that you have done at the time of training of the model. Otherwise, your model will be a biased one, even if you feel that, okay, fine, so I'm able to get a better accuracy or I'm able to get a prediction, but it will not last for the longer time. When I say it will not last for the longer time, it simply means that, so with the unseen data set, with the different test data set, so it will fail for sure. So you should follow the same approach. And this is what we used to discuss in every project, I would say, like almost 100% project, yeah. This is what we do in ML class.
So am I supposed to serialize the scalar, a standard scalar object?
Whatever
also?
you have done, actually. Whatever you have done, so you are supposed to take similar kind of feature. Many people, what they used to do is, so they don't try to do the scalar, standard scalar transformations at the time of testing. And they used to say that, okay, fine, I'm getting a result. Right. Okay. So now that is not a correct assumptions, I would say, because with the unseen data set, so for sure your model accuracy is not going to be same. And again, you will feel that, okay, fine, so maybe I have end up building a overfitted model, right? And we should not do that. So even if you're getting a result, correct result, like I told you, so sometime it feels, so as a beginner, you just feel that, okay, I'm getting a result, but no, that is not true actually.
Yeah.
You're not getting actual results. So you should not do that.
Okay. So I will do one thing. I will pickle the two files. One is for model, another is for a standard scalar. And at the time of predicting, I will call the load the standard scalar in order to standardize the data and then pass that data to the.
No, just new data set that you are trying to send. That data set you are supposed to convert, right? That data set you are supposed to standardize.
Yes. In a web service or through HTML web page.
Wherever you are trying to pass your data set in that server.
Yes.
Doesn't matter. So web service is what? Somewhere you are trying to host your model, right? So in some server, maybe local or maybe some remote server.
Yes.
So yeah, then all the locations wherever you're trying to call.
Okay. Thank you for the answer.
Yeah. Okay. Next question.
Hi, Sudhanshu.
Yeah.
Sudhanshu, I have a knowledge on some of the machine learning topics. Okay.
I think it's a live coding session for DL class. We have a separate like a ML class.
Yes, Sudhanshu. One thing is like
so generally, I don't prefer to answer any machine learning doubt in a deep learning and deep learning out into machine learning.
No, this is nothing to do with machine learning. I just wanted to know, like in deep learning, do you teach us like the pipeline?
I think this is this is the same thing I have discussed in the very beginning of your class. And this is what people used to do in my classes. So the entire pipeline we used to discuss. We don't like because in our very first class itself we used to claim that here you will not only try to learn I would say or try to do just something which is conventional. Here you will try to build the end-to-end product, right? Or end-to-end application you will end up building. So when we say end-to-end applications, so without following a pipeline, you can't do that. So even in a machine learning, if you will see our code, so we have built the entire ETL pipeline as well, which is a part of big data, right? And then like it try to go to the final model for the testing or training or anything, any such things. So yes, we always try to follow the pipelines, and through pipelines, we try to train it.
Okay, and I have another doubt in the deep learning part. I see on the previous class you mentioned like we need to do standardization or like normalization. So it should be done at the input stage, or like if we are adding some 2 or 3 hidden layers, it needs to be done on that layer
See,
also.
input is just a raw data input, I would say. So normalization, standardization, whatever you're trying to do in case of a neural network, it happens always in between input and output layer, which is nothing but a hidden layers. So whatever operations, whatever transformations you're trying to do, so that should happen in between the hidden layer itself. Okay. In that case. So input means simply a raw input, nothing else.
So at every layer we need to do normalization and or
no, depends upon my network architecture. I think very soon you will be able to understand. As of now, so you can see that many people have presented their system and then they were able to train the model, right? So they have already learned all those things. They have already gone through all those phases. So once you will go through all those phases, I think you will be able to understand these things in a better way. It's too early to talk about that and just to give you a 30-second of reply. Okay. Yeah. So maybe you will not be able to understand that 30-second of reply. So I don't prefer to give that reply, which you will not be able to understand.
Yeah, Shudhanshu.
Okay. Thank you, sir.
Yeah, go ahead.
Shudhanshu, Naveen here. I have a question in deep learning. Like, for example, we have solved a
Naveen, I think you are not audible properly. Can you please speak a bit louder?
Yeah. Are you able to hear me, Shudhanshu? Naveen here.
Yeah, Naveen, I can hear you now.
Yeah, actually, we have solved a couple of projects, which is a classification in terms of convolution non-linear, right? So my question is, we have solved like questions like image and data. I mean, image data set and
not
fashion.
only English, I asked people to even I asked all of you like class to build a model based on your own data set.
Family data set and couple of projects we did. So here my question is, for example, in an image, if the image contains 2 images in a single image, like cat and dog or Sachin and Virat Kohli,
that is a part of basically object detection. So object detection, so basically it's based on, I would say, a local response normalization, and I can say there is something called the RPN, and there's another algorithm for that, which is called as a faster RCNN, or I would say like SSD Lite, SSD mobile net. So we'll talk about object localization actually over there.
And what is object segmentation?
Segmentation simply means that, so segmentation, okay, I'll just show you example. Segmentation means we are just trying to mask or some kind of a things. So just let me show you.
So I know
so segmentation simply means that I'm trying to mask something. Means I'm trying to identify the periphery or perimeter of that particular object. So instead of detection means this one, I would say. So which is called as a localization as well. So this is called as a object detection. So in the single images, so we have a multiple images. So we are trying to draw the bounding boxes over there, right? So whenever we just talk about the bounding boxes, again, bounding boxes doesn't mean that it should always be in a shape of a square. There are pre-trained networks, so we try to define the shapes as well. So that is basically called as a detection, object detection. So it doesn't matter how many objects we have inside the particular object, I will be able to do that. Segmentation means this one. So you don't try to define the boundary boxes, you just try to define the mask shape of that one. This is called as a object segmentation.
In detail we'll discuss about in the class.
Exactly, we have to build a multiple use cases. So segmentation will come into picture after your object detection classes. So I think it will take 2 to 3 weeks more to get into a segmentation part, because the next after classification we have to talk about the object detection actually.
Okay, and one more question is In industry, do we follow OOPS concept or scripting concept?
OOPS concept actually.
OOPS concept. So
Yes.
because I mean I'm not a technical background, but I mean
no, I think OOPS wise, and I don't see any kind of a issue in between. While people say that OOPS are scripting, because in OOPS, what we used to do, nothing simple, create a classes, put everything inside the class, and then the method wise it will be same, and then we just try to create a one class variable, which we used to call as an object. We just try to call it simple, right? So there is no much differences in between like a scripting and OOPS, at least at this level. So if you have gone through the entire Python classes and if you have done all those things, right? Then I think this difference will be a basis differences, right?
No,
we do nothing.
because,
I just create a classes and put everything inside the class. Simple.
no, because I have gone through, I mean, various, websites and everything. So we'll be dealing only with scripting concept.
Yeah, generally they used to deal with the scripting concept because they don't try to show you application, right? But
Yeah,
in industry, can I say that we don't build we don't try to experiment something in our Jupyter notebook. We have to productionize it as well.
Okay, but
right?
people,
So in terms of productionization, so
people will commit an assumption that they will follow scripting concept. That is the reason I got.
This is what people think who have never worked into any single application in a real time.
Okay.
Yeah.
Okay.
People who have already worked into something and people who have already productionized something, they will not give you same kind of.
Okay. So,
yeah.
Okay. Got it.
Hello, sir.
Yeah.
Hello, sir. Sir, I want to ask, like, regarding in the previous class, you have discussed about neural networks.
Yes.
In the output section, you have told like when it generates the output first, and if there is any problem, then it will pass it to the loss function.
No, every time it will pass to the loss function, and so like whenever that is called as a learning, right? So every time, so whatever output you will be able to get, so output means nothing but the prediction value that you are able to get. So it will
Yes,
try
sir,
to compare with the actuals, and then if it will try to compare with the actuals, if there is a differences, so in that, so it will try to pass it through the loss. Now
sir,
it
you
will
have
try to
used two words there, like loss and cost. Are these
yeah, so basically
same
lost,
thing?
and I told you I think 3 or 4 times intentionally. If you will go through that recording, so intentionally I used to repeat these 2 words 3 or 4 times. I used to say that there is a very thick difference, very thin difference in between loss and cost, right? So difference wise, loss and cost is almost same. So loss function is being used in a terms of individual whenever we are trying to calculate the loss based on the individual inputs. So whenever we try to take a batch of input, so in that case we used to say that loss as a cost. That's the only difference. So loss function, cost function, or error function. So it's a name of just same thing, I would say. A little bit of context gets changed. So when I try to talk about only one data set, in that case I say that okay, fine, it's a loss. But
Like
when
the
I take
example
a
which you have
bunch,
taken
is the
single data.
the data which I have taken on that day, right?
Okay.
Simple one row I have taken, right? But suppose if I'm
Okay.
trying to calculate a cumulative loss, basically based on the multiple data sets, so that called as a cost now. So same loss will be converted to, so just a word, I would say, nothing else.
Okay, in the Excel sheet, like if you are taking one or two sheets, that's where we call as like cumulative data set is the cost.
No, I think again you are trying to misunderstood those things. So just wait for some time. So I think I'll talk about that. Something is like too early for your class to discuss. So you will
Because
be
sir,
able to
as I'm a
understand
beginner
it.
now, so that's why it's
You
really
are not
complex.
attending much classes, right? I think not the only 2 or 3 classes has happened in your batch, so it's fine.
Okay.
Not a
So,
problem.
Sudhanshu, is there any easy way to visualize what a CNN network is learning?
Yes, that is possible, I would say. So one thing is like you can try to plot a graphs of a train and test losses, and you will be able to find out that okay, fine. So this is how train and test loss is going on. Again, this is like just TensorFlow library, through TensorFlow library itself or through Keras API, you will be able to do that. So that visualization, training and test loss.
Okay,
Apart
do
from
you have
that, so
any
there is.
example?
Apart from that, many examples I will be able to give you, not only a single one. So training and test loss you will be able to visualize. Apart from that, so if you wanted to visualize entire model weights itself, so there is something called the detectron. So you will be able to find out detectron. So Yeah, so what a model has learned, what is the weight of the model, so each and everything you will be able to find out in this one.
Okay.
So weights and everything on every part you will be able to find out. So what kind of a weights it has learned, what is the total data which is going inside one layer to another layer, everything you will be able to find out in terms of a numeric value itself. So I'll show you in your class, I think. So there is a tool called as Neutron. So Neutron is available as an offline version as well as online if you will try to search. So even browser mode of these things is available, and just have to load the model over there, and it will try to show you layer by layer each and every weights.
Like
So
also for
every layer.
CNNs, is there any way to visualize like a
Okay,
which
Sudhanshu, one thing
layer
he wants to visualize, I want to add on. Okay, last 10 days back, a research paper came. Okay, I'm sharing the link, Sudhanshu, with you.
Okay.
Okay, even just share it here. I am sharing the GitHub repo as well as that both. It's a CNN visualizer only, an explainer basically. Okay, just wait.
No, Paul, it's R that I missed.
Just wait. Okay. In chat. Yeah, this paper.
So yeah, you can go through this one, and this is almost equivalent to your tensor board, I would say. So the tensor board that we have discussed. So in this way.
Thank you.
So there are many, I would say, libraries which is available. So with the help of that, so you will be able to visualize many different things. So depends what I'm trying to visualize. Train or test loss I wanted to visualize, or maybe I wanted to visualize the entire weights, or maybe a certain part of the weight, like I was using a neutron and I was able to visualize a certain part of the weights. I was able to get the numerical value, or how training happens in between, and how the shape is going to change if you wanted to visualize that. That also you will be able to visualize. Or else there is something called as a tensor space. So if you wanted to visualize a particular model into a 3D, so even there is something called as a tensor space. So you can try to go through this one. And let's suppose I'm trying to talk about this one. So even in 3D, so you will be able to visualize. Suppose if I wanted to visualize a LeanNet or LXNet or any other network, I will be able to visualize it, like from how it is going to convert this input images into final classes. So this is also a beautiful, I would say, 3D visualization things, which I used to discuss in almost every classes, right? And for every model, for every layer, you will be able to unwrap it, and you will be able to get actual pictures, I would say. So you will be able to get the actual pictures in terms of a visualization. So how this, when I say filters, so what kind of filters it is going to apply, and you will be able to see a very clear differences over here as well. Like when I try to apply a 3x3 filters, what happens, and what is the kind of a data set which I am able to get into a next. So not only a single visualization technique is available, so even a model wise, almost like all the major models is available over here for visualization. So including you with a YOLO. So again, it's a tiny YOLO that they have given. So yeah, these are the visualization things.
Thank you.
This is what you're looking for?
Yes, exactly.
So fine, no problem. So it will be discussed one by one in your class itself.
Hello. Hello,
Yeah,
Sudhanshu. Hello.
Yeah, go ahead.
Hello.
Yes, yeah. Instead of doing hello, hello, go ahead with the question.
Yeah, sir, I was training the RegNet model. So I was seeing some kind of thing that my loss was decreasing, but my accuracy was not that much increasing.
Okay, so your training loss was decreasing. This is what you're trying to say?
Yeah, yes, sir.
And what is the number of epoch that you have used?
I used like 3 to 4 epochs.
In that case, you can't even expect that. So at least try to train it for 1,000.
Because I was trying to train, but in local machine it can't possible, sir. So that's why I wrote a message that can we set up for
so yeah, in that case, GPU we are going to set up anyhow into our TensorFlow object detection. So
it will be good, sir.
yes, it will be better. So you can like train it for the lakhs of epoch. There won't be any issue.
Even I was trying with sir, Google Colab. It was also
The Google Colab, see, it always try to decommission it within 12 hours. This is what Google
sir.
Colab says. This is what Google Colab says. But according to my experience, so it even try to decommission it within 4 hours, right?
Yeah, after
so if
that
you
I was not able to train any models 2-3 days.
yes, yeah. So like even Google Colab has launched one feature for a USA region, not for India region so far so forth, where you can try to pay like a $10 and then they will give you a dedicated space where it will not get disconnected, right, per month basically. But yeah, for India regions it's not available, so you can use a VPN and then you connect to a US VPN and then you can use it Google Colab, which will be a dedicated one, not a free version of Google Colab that we generally use, right?
Because in local system is taking too much time.
It will take always. And again, so even in Google Colab, so they try to give a TPU, they try to give you a GPU, but it's not that powerful GPU or TPU that we can avail over the different cloud platform. So like P4000 or P6000 or Tesla K80 or maybe Titan X2 I wanted to use. So I will be having all the features over the Paperspace. Paperspace is one of the cheapest one, I would say, in terms of a GPU. And even over the GCP or AWS. So Google Colab doesn't provide that much. So it's an open source, right? So in a free version,
How much will it cost?
So Paperspace actually is going to cost you, depends upon the users. So it's basically a pay-per-use model that they used to follow. So as per the use, as per the model training, so it is going to cost you, but again, not much, I would say. Even if you will try to train your model for the entire month, so your bill will not be more than 15,000 to 16,000 for the entire month if you will keep on utilizing like a P4000 or P6000. If you are going to use maybe like a Titan X2, in that case, yes, cost will be high. But yeah, if I'll talk about a Tesla K80 or if I talk about a P4000, P6000 processor, so in that case, this will be the on an average cost that you are going to get for the entire month.
So on Azure or something we can train free?
On Azure, same thing you can take. So like it's a GPU name which I'm talking about. So this GPU is available in everywhere. P4000, P6000, Tesla K80, and then this Titan X2 is available everywhere, even in Azure, even in GCP, even in AWS. But if you are going to avail the same service from Azure, so your bill will be almost 2.5 times than this one. Same like hardware you are going to use, but yes, your like a
sir, when will be the setup for the GPU, sir?
So I think you have already done a setup for TFOD, right?
Yeah, we have done.
Then I think in object detection, so I'll teach you. Like it's just a 5 minute of job. Set up a TPU, like set up a GPU, just a 5 minute of job.
So I want to ask.
Provide everything.
I have another question, sir. So what is? You were telling that what is the receptive field? I want to know, sir.
A receptive field. Okay, what is your understanding about a receptive field?
I was looking on the internet, so I got to know that it maximize the pixel which you are looking for. I think so. I want to ask something.
So just enhance it. So like kind of an enhancement, I would say try to do to the pixels that we are looking for. So receptive field is nothing but so localizing something which we are actually looking for, the kind of feature.
So that means with the pixel which we are looking for, it maximize the look for that.
So localize, I would say. Okay. So there is a receptive network that we are going to discuss for sure, right? So the kind of a network is try to like localize something. So that is something called as a receptive field. So again, I'm trying to show you one diagram called as this is the YOLO tiny. And you only look once basically. So in this one, what happens is try to take all the pixels and then it try to identify the multiple objects into a single frame itself. So it will be able to detect multiple ones. So it is trying to localize it actually. So it is trying to use a different receptive field, I would say, for the different kind of pixels or objects.
It means the network looks for every pixels.
Every pixels, and then it will try to localize it. It will try to create a bounding boxes across that one, basically.
Okay.
So bounding boxes try to create, that is called as a receptive network.
Thanks.
Yeah. Next question, please.
Hi, Sudhanshu. This is Vinil. Thanks for this opportunity. So I flattered with the course structure and then the price and everything. It's very good. Yeah. Thank you for that. Yeah. So I have some experience in data science. Currently, I'm working as applied data science in one of the MNCs. So to want expertise in the deep learning, especially in NLP, I found that this course is very helpful. I have one question, like going through something like I came to know. So this course can cover like how, to get an understanding how to design an architecture on a machine learning or a deep learning model on a very large data set or a moderate data set?
Yes, sir. Yeah, we are going to cover it actually. So on very large
Okay.
data set as well, and small data set as well, and even moderate data set as well. And again, I think I have launched one community activity, right? So I think it is going to start from this Saturday and Sunday. So in
Yeah.
that one, so I will be talking about domain by just architecture discussion, no coding, nothing. So
Okay.
just architecture discussions I'm going to do, like how we design the solutions.
Mhm.
So I'll talk about those things into a generic way, as well as I will talk about with respect to industry example, with respect to different domains. Try to
Yeah.
attend the class, you will be
Sure,
able to
sure.
get some insights over there.
Okay. Okay. So that course will also cover any deployment problems we will face when
Nothing,
we.
no coding, nothing we are going to cover in that one. Everything will be theoretical, but yeah,
Okay.
deployment strategy, retraining strategy,
Mhm.
everything I will be able to cover over there. So even what and all tools that we generally use, what and all security tools we use, what is our DevOps infrastructure that we use, everything
Okay.
I will be covering over there. When I say architecture doesn't mean, or it not only restricted to a data science. Architecture means when we used to build a product, so data science will be a backend, right? So, but there
Yes,
are
yes.
many more things which comes into a picture in terms of architecture, designing of a application. I will be covering many things over there. Not many things, almost everything I will be covering over there. So, and the entire flow as well, theoretically, practically.
Okay.
So we used to discuss and we used to showcase in a class, which will happen in your class. But yeah, so because the thing is like everyone knows that how to run a code into a Google Colab by copy and
Yes.
pasting code from the GitHub repository or from somewhere else.
Yes, yes.
And but people don't know like how actually like they should explain a project or how actual project works. There is a huge gap, and again like there is not effective resource which is available over the internet for code part. I can say that yes, every second person used to upload a code somewhere, and then people used to do a copy and paste. So without having a knowledge that okay, finds how in the best possible way I will be able to utilize it, and whether this score is basically like it's consumable or not. So even people don't know about that. So I'll like keeping these things in the mind. So we have kept this session so that I will try to show you the actual architecture, then how things actually works, and then you will be able to get a better insights about the entire infrastructure itself. Because what I feel is like if you are going to explain a project, a data science project, so unless and until you don't have an understanding about the entire stack and entire architecture, algorithm is one part that you should know for sure. Algorithm mathematics, that is one part, and which is a core data science, which I always suggest people to like they should learn all those things in a much better way. That is one thing. But apart from that, they should learn architecture as well, because as you will go inside the industry and as you will start building an application, so you will face that a data science model is not giving you much pain, but your like a data size or real-time predictions or your architecture or scalability is a major pain points. Right, and these pain points we used to handle. Yes, there is a one aspect which we used to handle from the data model itself, but again, many things you will not be able to handle from the model side itself. So many things we used to handle from the architecture perspective when we talk about the actual product. So this is keeping these things in our mind. So I have designed this 3-week long curriculum. So I think it will happen for 9 days. The 3 days in a week, and 2 hour I have given, but yeah, so I was assuming that I will have to take classes for 2.5 hours if I have to complete it in 9 days. So I think the session will be beneficial for you. So
Yeah,
just try
sure.
to go through that. You will get some
Okay.
actual insights theoretically.
Yeah, okay, sure. Thanks for that
So,
community activity. And
Sudhanshu,
one more question, Sudhans. I have just it's my off topic. Is there any time series analysis course are you providing?
Not time series analysis, a special course we are providing. So there is a time series analysis in our machine learning, which we have already
Okay.
included. Just a small single model which we have. Apart from that, so we have many more applications, but we don't discuss those application of a time series in a curriculum, because sometimes what we feel is like unnecessarily we are trying to create a headache for us. Because if people are not able to grasp those concepts, so and again, if for every small thing, even for the variable declaration, if they will start asking us a question, right? Once after having a discussion on architecture and mathematics, so we generally avoid those kind of situation, right? Because it's completely fine. So like we can go in like any depth or any breadth, we don't have any issue. But So, but yeah, like even like in upcoming batches, like I always improvise the batches. Even the day I have launched your batches, so I have added many topics. The day I
Okay.
used to launch machine learning batches, so from the previous batches, I always try to like launch. Like I always try to give a more number of topics. So even new machine learning batch which I am planning, so I have already added 3 different models which was not there
Okay.
in my. Although already like my previous, I would say syllabus is too huge, but still we keep on adding a new models and yeah. So I was planning for time series model as well. So I was wondering that if I can increase a few more materials. So
Sure.
this time we are going to increase it, but as of now it's there into a machine learning model. Time series is there,
Okay.
and the people who are from the machine learning batches, so they may give you the answer that yes, time series is there.
Okay.
So just to add to previous question about the architecture. In
Yeah.
architecture, are we going to talk about the batch injection, stream injection, or
Yes, we'll talk about all those things. Everything will come. When I say architecture, right, and when I talk about the scalability, when I talk about a solution designing, so these
okay?
are the factors like batch mode or mini batch or real-time data, which you try to say as a streaming mode, right?
Okay.
So
Yeah.
everything will be captured and everything will be covered over here theoretically.
Is it like we are taking any standard Azure cloud or AWS
Cloud is
and
nothing, right? Cloud is just a platform to host your like an infrastructure. I will be talking about a cloud comparison. So which cloud, in which cases you should use, which cloud provide what kind of a services, which cloud don't provide what kind of a services. So I will be doing a comparison because when we talk about architecture on an industry level, so suppose your client is having a tie-up with the Azure cloud, right?
yes, yes.
You will, so even though Google Cloud is providing a better services, the services that you are looking for from Azure, but still
Mm,
you will end up using Azure itself,
yes.
right? So
Yeah.
basically you should know the comparison. And again, in our industry, when we try to deliver a product, so it never works in that way. So I will be covering all those aspects as well.
Okay, I'm a bit confused. Like when we are talking about architecture, right? We were doing a computer vision use case. They were talking about you need to put it in your blob storage. From blob storage, you need to create a
Attend a
pipeline to
class,
your next.
attend class, you will get to know. Soon we are going to
Okay,
start, right, from this
okay,
Saturday.
okay. Yeah,
So
sure.
attend a class. I think
Yeah,
all of your doubts that you have in your minds as of now,
yeah.
I think it will be clarified very soon.
Also,
Okay, okay.
Sudhanshu, I'm working on a NLP use case, and I've been asked to extract key phrases from the document, and I've used
Good then.
Spacey to use to extract compound nouns, and I've even used text blob to extract noun phrases. But there's a lot of noise, so I used frequency, length, and total word, and I'm using a weighted sum to filter out these phrases. Is there anything else that we could try?
As of now, it's fine. So as of now, it's completely fine. But let's see. So like how better our bot elbow model is going to perform as compared to your Spacey model. Yeah. As of now, as a beginner, yes, you can use Spacey, you can use a text blob, you can use NLTK, you can use a Stanford NLP as well. And but in our class, as you might be aware about the syllabus, so we are going to use a deep learning based model as well, a transformer based model, GPT-1, GPT-2, BERT, ExcelNet, and all those things. So as of now, if you can try and try with those models. I think
Are those
you will
videos
be able.
uploaded in the dashboard?
Video is not available, code is available for
Okay.
everything. Yeah, so you can download a code from your dashboard and then you can go through it. We have already built an application, so you can try to utilize the application. But again, you are going to face so much of hurdles if you are not aware about like a BERT model, and if you're not aware about the architecture of the GPT-1, GPT-2, or excellent model. So my recommendation will be wait for some time to get on that level, and after that, I think you will be comfortable.
All right, thanks.
Hey, hi Sudhanshu.
Yeah, go ahead.
Just a follow-up question on top of it. Can you please upload the videos of CNN for the pre-recorded videos which were done previously? Because I can see
I
only.
can do that, but try to go through the classes, right?
Yeah,
See, every classes will be a different one. This is generally what happens is, so if you will watch my recordings, right? So I have taught a same topic many times, and like for the same topic, many videos are available, right? If you'll go and search in a YouTube, again, it's very difficult to search on our YouTube channel. I know that.
Yeah,
I completely
perfect.
agree with that. So every time I used to add something, right? Every time. So I used to try to explain all those things in a sometime in a much better way, right? So you can wait for your classes. CNN wise, I think yes, like recordings is available from the parallel batches that has joined even this discussion. right? So, but still, wait for your discussion. So
the
maybe
reason
I'll
for which,
discuss in a much better way, like a
yeah.
much better way this time. This is what I do every time. Every time I try to pick something, because see, the thing is like people keep on launching this new things, and what I do is like I keep on reading these new things, and whenever I used to take classes, okay, fine. So now let's talk about in this way this time. So this is the new dimension which I can add in my teaching, right? So I keep on adding a new dimension all the time. You
I
might have seen
completely,
that. Yeah, you might have seen that, like the way I have taught a Python itself, right, in a different classes, right? And now in a community, even the way I'm teaching a Python, again, it's different, right? So a
yeah,
different I would say style that I have adopted. So it depends actually on me.
yeah.
So
So I completely got your point. What I've done, I've previously attended your ML lectures, and I've completed up to EDA. So the EDA is same as replicated for the DL ones, for the
it's same,
DL
yeah, till
lectures.
Python
Yeah,
part. So I don't consider EDA as a part of
yeah,
deep learning or
perfect.
machine learning. I consider that as a part of just Python, I
So
would
I've
say.
directly started with that NLP
Have
and
you
the
completed
neural
all the
networks.
EDA, all the 10 EDAs? Because we have shared 10 EDAs file, right? So
No,
have you
no,
done?
I'm just doing it one by one, how it goes. I'm just
Do
taking it
watch
one by
each
one.
and everything. You will get a very good understanding about
Yeah.
Python. And just try to write a code by yourself. That
All
I will
right.
recommend you. So all the 10 EDAs just completed. It's a huge one. If you have opened up a file, all the 10 EDAs. So I think except one EDA, so every EDA is two use. Two use means it's like in two depth. So we are trying to do a EDA. So just try to complete it. It will give you a very good insights. It will try to give you a very good hands-on practice as well. And after that, so you can feel that, okay, fine. So now I can do a coding. I can do a real coding, right? So keeping these things in mind, we have uploaded those 10 ideas. So just do
Okay.
it by yourself.
Okay.
Code is already available, right? Data set is already available. Result is
Yeah.
already available. Entire things, but don't try to follow the coding style which we have followed. Try to write it out by yourself.
All right. All right. Thanks a lot.
Yeah.
As also, in the last class, you told that activation functions is used for the normalizing the data. But then I'm unable to relate how it is used to achieve the non-linearity. And also, like, yeah.
Don't worry, Utkarsh. Try keep on attending the classes. Other people are able to understand it, right, from other batches. You also will be able to understand it. Don't worry. Yeah. So
yeah,
sometimes it's too early to answer something. So yeah, even you will be able to understand it. Then you will see it by yourself.
Okay.
Sudhanshu, I had a question. So see, during calculation of output size through a convolution layer or through a max pool layer, we say when
Calculation
padding,
of output size.
yes, output size.
Okay.
So we say when padding equal to same, that means the input size and the output size will be same. Will that be true even in case of stride equal to 2?
Yes, yeah. So even stride is equal to 2 and padding is equal to same if you have kept, right? So in that case, the input dimension that you are trying to give, the output dimension that you will be able to get. So yes, like it will be same for sure.
Okay, because I was looking at the ResNet, architecture and the output size that have been provided. So con 1 has 112 by 112, and then there is a 7 by 7 con player with stride 2, and then the next con 2.x has 56 by 56. So that kind of confused me as to from where then.
So have they kept these things as the same?
They have not mentioned about the padding.
Which model you were looking into?
ResNet.
A ResNet model, right? So no, if
And I'm
you have
looking at the
kept these
document
things,
that you had
no.
shared.
If you have kept these things as the same, right, parameter, if you have set is equal to same, so in that case, if you are trying to give 112 into 112, so the final outcome that you are going to get will be having a 112 into 112. Doesn't matter what kind of a strides that you are going to use, because it try to do a pool like a padding in between, and then on the padded data sets, it will try to like give you the same output. So this is the meaning of a same actually. If you're not going to keep a same, then in that case, what happens is then it is going to apply a formula called as n plus 2p minus f divided by strides plus 1. This is the formula which gets applied.
True. So in that sense, the calculation here as to how the output size reduced from 112 to 112, 112 into 112 to 56 by 56. And correspondingly, if you look at across the layers, it is reducing by half, exactly half. Though
No,
there are
which one? Which one?
I'm
In which
looking at
one?
I'm looking at ResNet.
No, see, don't look into ResNet or any other net, I would say. So no, this is not a correct way of understanding anything. So suppose if I have taken like a 5 cross 5 over here, right? So 5 cross 5, if I have taken in this particular place, 1, 2, 3, 4. Let's keep this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And let's suppose I'm trying to apply maybe a 3 cross 3 over here. So if I'll try to apply a 3 cross 3 in this particular place, so may I know like what is a size that I will be able to get over here?
So 5 minus 3 would be 2, 2 plus 1 would be 3. So it would be 2 by 2, 1, 2 by 2 into 2, or 3 into 3.
Okay, 3 into 3 actually will be able to get 5
Yeah,
minus 3,
yeah, 3 into 3.
so plus 1. So basically it will be equal to 3. So here I will be able to get 3 cross 3. Now if I'm going to keep a strides is equal to 2, then what will happen?
Then it will get divided by 2. So that would be 5 minus 3 would be 2, and then 1, 1 plus 1, 2 into 2.
So can I say that it will be 2 cross 2 in this case, right? This is what you will be able to get. Now, if we are going to keep same, so in that case, what happens is, so the final outcome that you will be able to get will be having 5 cross 5, whether it's a stride 1 or whether it's a stride 2. That is the meaning of same, I would say. In general, if I'm not going to keep it as a same, so for sure it will try to reduce. So in case of a strides is equal to 1, it will be 3 cross 3. In case of a strides is equal to 2, it will be 2 cross 2. But if like I'm trying to keep these things as a same, so it doesn't matter what is a strides. So yes, based on the strides, it will try to learn the filters. That is one thing. But the final dimension of the images that you will be able to get, it will be having a same. Same means same as your 5 cross 5. So here you will be able to get, instead of getting 3 cross 3 or 2 cross 2, you will be able to get 5 cross 5 and 5 cross 5 over here. This is the meaning of same actually.
Okay, so I should not really look at the different variants which has con1, con2.x, con3.x, and
no, not at all, not at all. No, not at all. So in between the layer, just try to look into that one, I would say. And apart from that, so yeah, ResNet or LeanNet or like maybe Inception or BGG, any model doesn't matter. Like we can keep convolution is equal to same over there, and then in that case, like it try to give you the same number of the pixels as an output, even after applying the filters.
Okay, another question is for Inception net. We saw that the intermediate layers, there was a softmax output as well. So how does all the three outputs, the final output that comes in and the
see, no, it happens in that case. So if you remember the class that I have taken last time, and when I was showing you these things, so let's go to the paper of Inception net. When I was discussing about this thing, so I have clearly said that I think Inception net research paper. So
I think you
see,
said
I have, it's fine. So everywhere will be the same. I can get it from anywhere. So see what happens is, so I was talking about like there was a 3 output layer that they have designed right in between itself. So here, if you will try to find out that here, so I was trying to talk about this one, that they have kept this things as a softmax. Again, here we have a softmax. Again, here as a softmax. So as we know that Inception network is a depth of the network is 2 hues, right? So suppose as a trainer, so suppose like as a person who is trying to train a model, right? So maybe instead of training a model till this part, because we are training a model till this part means what? We are trying to do a convolution pooling, and then fully connected layer in which we are trying to pass the data set, where it will try to learn based on the features that we have extracted, based on the convolution pooling or Inception network that we have used in between. Right? So what if I can try to test it in between itself, if I don't have to like train a model till this layer. So in that case, can I say that if I'm trying to take a model only till this layer, if I'm trying to take a model only till this layer, so I will be able to get a lightweighted model as compared to a model which I am trying to take, as compared to the model which I will try to take till this layer, right? Or as compared to the model in which I will try to take the full network, right? So can I say that I will be able to, so in all those 3, so can I say that model size will be different? Can I say that number of parameters that I'm trying to learn will be different?
Correct.
right? So whenever we look for so basically inception model was a depth of the model as well as it follows the breadth of the model. Depth and breadth both used to follow BGG. So BGG just try to follow, I would say, like depth of the model, but inception always try, even if I'll talk about ResNet, right? So ResNet is basically a depth of the model, I would say, because we have seen a ResNet 34, we have seen a ResNet 50, we have seen a ResNet 101, we have seen ResNet 150 plus as well. So those models was a depth of the model. This is having a breadth of the model, and there is some advantages. We have introduced a inception layer in between, and inception layer we have introduced based on some of the calculation that, okay, fine. So calculation, as we have already discussed in a class, right, in very detail, that why we are creating an inception breadth over here. So what is the advantages that you will be able to get as compared to taking just a 5x5 or 7x7? So why we have divided it and we have taken the identity, I would say, convolution layer. Or I can say like a 1x1 convolution layer. What is the advantages that you will be able to get? Identity means it's different. In ResNet, generally we use a word called as identity, where we have a steep connection. So basically what people have figured out is that, okay, fine. So if I'm able to get accuracy even till this layer, even till this inception network, so do one thing. So I will not train it further, right? I will not train it further means, so I will not try to learn these weights. So I will not try to learn anything over here. I will just try to learn till this one, and then I will connect directly. I will try to pass this things into a fully connected layer, and finally I will be able to get the output. So in this case, this will be having a no significance, I would say. This network is not having any significance. Only till this particular layer, I will be able to use my model, or I will be able to use my network. So keeping these things in mind, people have extracted this softmax functions in between the layer itself, so that even through a middle of network, without using the whole network, you will be able to train it and you will be able to test it. And again, this is always like something that we used to experiment in terms of, so we try to take output here, right? And then we try to experiment it. Okay, fine. So model size is less, but whether it is able to give me accuracy, if it is able to give me accuracy, fine. I will not even include these layers. So this is just a experimental things, I would say. So sometimes we just take a layer till this point, sometimes we take a layer till this point, or sometimes the entire layer we used to take. Depends.
So are there multiple variants of the same model which we can use, or within the same model?
So within the same model itself, we have a variance and we have a multiple variants as well. So even last time, so I was talking about the tables, right?
Yeah,
and
V1 to V4.
Yes, even InceptionNet with the ResNet we have seen,
yes,
right?
yes.
So V1 model, V2 model, even benchmarking we have seen, right? So all those things we have seen. So there are a variants of the same InceptionNet. So InceptionNet, I would say, discovery or InceptionNet research started since 2014, right? And it went till 2016. So in between these 2 years, so people have released many versions, I would say. Because if I talk about ResNet came into a picture in 2015, right? So they have included this 2015 model as well into a further InceptionNet that we used to call as a InceptionNet ResNet V2, or even in a V4. So that variations are there. So there is a variation across a model, and again, the initial version is called as a Google LeanNet generally, right? So basically, there are multiple variations as well, which is available inside the InceptionNet based on the monthly release of the InceptionNet, and so there is a variation that you can create within a model as well. And this is what we are discussing as of now. So we are talking about in between intermediate softmax layer. So even you can try to take 3 different model, you will be able to create just within a same network as well. So model by taking just a data set or like a weights till this point or this point, all the entire network itself. So all these 3 things are possible.
So there is some parameter which is available which helps in deciding till which layer.
Yes, exactly. There is a parameter. So once you will invoke a method which is designed for InceptionNet, you will be able to find the parameter and you will be able to restrict your model weights even till this point. That is available.
I also read that there is a weighted sum fundamental for auxiliary weights. So like 0.3 into the auxiliary softmax 0 plus or 0.3 into softmax 0 plus the real loss. So that's how they calculate the total loss across the network.
Yes, yeah.
So on the final softmax, which is I think is softmax 2 here.
Yeah.
So then when they calculate the total loss, they take the loss across all these intermediate softmax functions and then calculate the total loss. Is that how it works?
No, actually, see what happens is here, why I will try to calculate a loss over here and then over here and then I will go over here. Can I say that I will not try? So see what happens is, suppose if I'm trying to send data in this layer and then in this layer and then in this layer, because here we have a separate fully connected layer, here we have a separate fully connected layer, and here we have a separate fully connected layer, right? And now what is the meaning of fully connected layer? So fully connected layer simply means that, so it will try to basically learn the weights which it has convoluted weight it will try to learn over here, right? Convoluted feature it will try to learn over here. So basically, like, there is no interconnection between this one or this one, I would say, in general. So if you are trying to not to take this one, but let's suppose I wanted to get into a situation where, so have you seen a ensemble technique? So in ensemble technique, generally what happens? Can I say that we try to take a multiple decision maker, right? Multiple decision maker, basically random forest if I talk about, or ensemble technique. So in that case, so everyone will try to give a prediction, right? And then we try to go ahead with the voting, and then majority wins, and then this is how we try to decide the classes. Can I say that?
Yes.
But in case of a random forest, can I say that the base model is nothing but decision tree itself, right?
Yes.
So even you can apply that same fundamentals even over here. Suppose we have a 3 sortments, right? So one approach is, no, I will not consider this. I will not even consider this one. The another approach I would say is, so fine, what I will do is I will try to train, I will try to pass a data even over here, and even over here. I will try to get output from all for the same classes, right? And then I will go for the voting.
So basically they all poll for it.
Yes, they all poll for it. So similar way as an ensemble technique, right? Because this is what we do inside an ensemble technique, right? So even that feature, so it depends upon us, like how we are going to perceive this particular network, and then how we are going to make a prediction. So maybe you will feel much confidence when you are trying to go ahead with the voting, which you are able to get from the 3 predict ads, right? Instead of going with the 1 predict ads, right?
Yes.
Can I say that your model will be much more confident, like if you are trying to predict from the 3 persons and then you are trying to take the votes, right? This is based on that we have designed the ensemble technique, ensemble learning, I would say. So yes, you can follow the same thing even over here, and that provision is also there, that factor is also there, and where it is going to help you out. Again, so this is the single model, like based on that we are trying to decide. It could also possible that I will try to take maybe an inception, I will try to take a ResNet, I will try to take maybe a VGG, I will try to get an output, and then I will go for the voting. Also possible?
Yes.
Yeah. So it depends, like how we are going to finally achieve our final outcome.
Okay. Thank you very much for the nice explanation. Last request I had was, see, somebody was talking about time series. Can we take an example even in deep learning around time series, maybe using LSTM?
One example is already there. LSTM based example is already there, and don't worry about that. So like even in my machine learning class, when I have released a curriculum, so I have not even mentioned a time series curriculum over there, but we have discussed it.
Okay.
Right. So it was not a part of curriculum, but still we have discussed it, right? Same thing.
Yes,
See,
yes.
example wise, there is no problem, and there is no shortage of example. We don't have to even build any kind of example. We already have that in place. But sometimes, like I told you, sometimes we feel that, okay, so like because I always try to go through your chat. Like people used to pick a support team, right? Or people used to drop a mail. So chat wise, and what I feel sometimes is like people are maybe not ready for this kind of a knowledge or in-depth knowledge. People are just ready for like overall, maybe just an overview, right? People are not ready for in-depth. Sometimes I feel that no, I should give that. So based on that, I used to make a decision, right? Because unnecessarily it will be painful for us. Because if we have discussed a machine learning, if we have discussed everything, so when we go into a time series, at that point in time, what I think is like, okay, fine. So now at least I should take a less pain to explain these things. But still, if I have to go through the entire scratch of the model and then I have to explain those things, so like unnecessarily I will end up wasting my energy for nothing, right? I can explain, but and that's the reason, like sometimes we include something, sometimes we don't include something. But time series wise, I was getting a huge demand from every one of you, so that's the reason in machine learning I have already like I discussed, Virat has I think already discussed time series in every classes. So we are going to increase the syllabus for time series as well in terms of a number of examples. Plus same thing will happen with your deep learning. RNN LSTM based example we already have in place. LSTM and GRU based example. We just have to like create a tab inside your dashboard and put code over there and discuss about it. That's it.
Okay, yeah, that would be really helpful. Thanks.
Yeah.
Thanks, Sudhanshu.
Yeah. Okay, next question.
Hello.
Yeah, next question, please.
Hi, Sudhanshu. This is Bharat.
Yeah, go ahead.
Do we have a discussion forums where all these questions are listed down and possible answers are workarounds or troubleshooting issues?
No, sir. See, what happens is, so I was giving a flexibility or discussion forum as well, and there was a groups as well, which was there, right? For many of the batches. But generally, what happens is, what I have seen is, like, instead of doing a productive discussions, people always get into any XYZ kind of a discussion, and this is the nature of the people. I can't stop it, right? And I don't want to control those things. So that's the reason. So we have a discussion forum, like we have our own support team itself. And again, so when people used to discuss, so they keep on sharing unrealistic material, or sometimes what happens is they create a confusion as well. And so what I feel is, like, it's always better to ask all the question to us, because from our side, so at least I can believe on my guys who used to give you a support. I know those guys, how much qualified those guys are, like, who used to give you a entire end-to-end support. So it's better to ask us instead of getting into a blah blah kind of a conversation. I think in this entire universe, so there are many discussions forum which is there, right? And people used to post their own thoughts. So for that, I don't think that you should look for your own batch conversation. So you can look for any kind of a discussion forum. If you have any specific doubts, it's always better to ask to me, right? So that I will be able to give you at least like a knowledge, like a information based on my knowledge, right? And at least, like, you can try to cross check with all the platform which is available, instead of deviating yourself from the blah blah kind of a discussion.
No, what actually I am trying to figure out is, because people will work with different cloud environments in Azure, say, like, AWS. Once they are getting into any issues, rather today or tomorrow, we can have an overview of that. That's the
No, still, sir, you will not ask all those things. And even if you are facing an issue, right? So most of your group mates or most of your discussion forum people will not be able to solve it. You will end up asking those questions to us itself. This is what I can tell you from my experience, right? So when we have to give all the answer, then there is no need of discussion forums, right? Unnecessarily to create a chaos. And that's the reason I have just removed it. Even in your dashboard, right? You might have seen that there are certain changes, certain tabs I have already removed. I have deactivated, right? So there was a multiple tab which was there in a very first class, but I have removed some tabs, and again now you have just a home tab and a grid tab, right? Just I have removed it because that was not necessary. I think people are not ready to take those things.
Okay.
Yeah.
My next question is, what do we use for data labeling for images in a real-time world?
So there are many tools. There is a BGG tool is available. There is a image, lots of image aggregator which is available. So generally in your first class, we are going to talk about something called as a label IMG. So label IMG we are going to use, and that will be discussed in your class. We'll talk about everything. We'll even show you like how to annotate a data set, how to label your data set. So label IMG in general, as a beginner, everyone uses that. So we'll show you that as well. But apart from that, so there are many labeling tools which is available. We'll show you that as well.
All right.
Yeah. Next question.
Sudhanshu, Virat here.
Yeah, go ahead.
Most of the people they are willing to talk about this ML challenge that we have launched. So what I would suggest is that let's do a screen share and then explain.
Virat, you can go ahead. You can discuss. Yeah, you can discuss about that.
Right. Thank
Leaving
you.
up to you.
Okay, fine. So guys, just let me know once you are able to see my screen.
Yeah, we can see.
Okay, thank you, Sarvanshi. So what you have to do is, this is our homepage, right? We'll ping this in the chat. Sarvanshi, if you'll be kind enough to please ping it in the chat for everybody to see. Yeah. So this is our homepage, guys, and the basic questions that I will be answering is that how to actually go ahead and join the challenge. What are we expecting from you, and what are the rules and all for those? And terms and conditions in detail, you can read it here. FAQs we have given also. You can read about your FAQs as well. So first things, how to go ahead and join this challenge. So you'll have to click on this sign up button, not login. Right? Please click on this sign up button. Enter your details and just click on sign up. And once you have signed up, you'll get an option to log in. It will ask you that, okay, you have been successfully signed up. Now please go ahead and log in. Then you can go ahead and click on login. right? And then just give your your email address that you have configured and the password that you have given, and just click on login. So let me try to log in, right? And I'll show you what after that. Let's say you have logged in now, right? So this is the previous challenge, the chatbot challenge, right? So, and this is our new channel, the machine learning challenge. So if you click on this, so this competition has already expired, it has been closed. So there is no need of going there, and this competition is already running. So just click on this more, and then you will see a lot of things here. So if you want to join this this competition, you just have to click on this join competition button. You'll get a pop-up, right? By clicking on this OK button, you agree to the terms of and conditions of this competition. So before clicking OK, I would recommend you to go ahead and read the terms and conditions, right? Whether you agree to them or not. This is the counter that you are seeing here, right? These many days are left in the competition, and then these are our solution requirements, right? So this is what we are expecting from you. Again, you can go ahead and read about it, but I will just summarize it, what we are exactly trying to we are actually trying to get done here. And this is the section like related to prizes. So the first prize for the winner is rupees 15,000. Second prize is rupees 30,000, and third prize is rupees 20,000. Again, once you click on,
you can talk about a winners as well, Virat. So like a chatbot challenge winner. So I think we have already posted in the
yeah. Let me cover this, and then I'll go to that their testimonial section as well.
Yeah, sure.
Fine. So once you click on this join competition, and once you accept the terms and conditions, you'll see one extra tab here just beside rules, which will talk about submissions as well, right? So fine, and then you can go ahead and submit the links for. We'll talk about it. What are the links to submit? Now, what are the problem statements in our machine learning challenge, right? So we have divided our machine learning challenge into 3 parts actually, right? So or 3 bundles, you might say. So there are 3 bundles: machine learning challenge 1, machine learning challenge 2, and machine learning challenge 3. You need not solve all the 3 bundles. It is not required. You can select any of these bundles, be it ML1, ML2, or ML3, right? And whatever bundle you are choosing, right? You have to solve all the 3 questions. Let's say that you have chosen ML challenge 2 bundle, right? Then from this bundle, you have to solve all these 3 questions. If you click on individual questions, right, you'll see a brief problem statement, not the entire explanation, a brief problem statement, what you have to do, right? And to download this data set as well as the problem statement, you can go ahead and click on this, download all files. It will redirect you to a Google Drive link. And then you can just go ahead and click on this download. You will be able to download the data set, and you will be able to download the problem statement as well. So this is true for all the problems that we have given. Now, once you have solved it, right, what are our expectations from you? So that you can see here, right? So based on different bundles, we are requiring you to deploy those bundles into different cloud environments, right? If you are choosing ML challenge 1, you will be needing to deploy it to GCP, and so on, right? And point number from 2 till 8, right? They actually define what do we need from you, right? So we will need a very good EDA, descriptive analysis of whatever you have done. Why, if you have done a certain step, why you have done it, right? What was the reason behind it? And if you were not going to do it, what was the impact that we would have incurred, right? You'll have to create a documentation, right? And now documentation will be mainly consisting of 2 things. The first thing will be your high level design, like what are the components that you are using, what are the technical stack that you are using, what will be the flow of your data from one point to another after either training and for prediction, right? Then again, you are supposed to create a UI, right? That UI will contain things for both bulk testing as well as single instance testing. In your document, you will have to include like whatever methods you are defining, whatever classes you are defining. You'll have to define everything. Like if you are familiar with how industry-based or industry standard documents work, whenever you are creating a low-level design document. So we are expecting that kind of a scenario here, that everything in detail, whatever you have mentioned, whatever methods you are calling, whatever methods you are writing, their input structure, what output they are going to give, and what is their functionality, why they are being used, right? All those things, they should be mentioned in detail. Your failure point analysis and the sequence diagram for the flow, that also should be mentioned, right? If you're not familiar with these terms, again, they are very generic terms. They are used in all the software industries, right? And you can very well go ahead and Google them, right? Then again, after that, once you have deployed your model, right, that's not where your job is completed. So generally when you work in industry, you have to work or you have to define a model retraining approach as well, because model training is not a one-time job. So you'll have to keep on retraining your model so that your model keeps on performing good or unseen data also, right? So that approach also we want you to define. And again, like there was a lag that we found out in terms of chatbot and all, that people whenever we asked for preparing the video, right? So they were just preparing a video with where they were showcasing how their application worked. No, we do not want that. See, the end goal, why we are asking you to create a detailed documentation and a detailed descriptive video is that, right? It will actually, we'll upload it to our channels, right? The first thing, right? And it will make a social media presence for you, right? Whenever you are sending a resume to an employer, you can mention the GitHub link, right, for your documentation. You can mention the link of the video for your things that you have done. Now just imagine how it will keep you apart from other candidates which have not done those kind of things. And the second goal is that, right, if those videos, they are getting uploaded to our channel, right, so it should cater to the needs of the community as well, right? If someone is watching it, they should be able to understand that what you have done, why you have done. And the end goal is that the person who is watching your videos and the person who is watching or reading your documents, right, they should also be able to replicate what you have done. So keeping that in mind, please go ahead and create all the stuffs, whatever you are going to do. And as Sudhanshu was asking, right, so let's have that section as well. So if you go ahead at the bottom, right, so here we have testimonials for all the 3 winners that we had for our chatbot challenge. So you can go ahead and see, like, we have published, right? And yeah, so for you also, if you go ahead and try to, like, if you win it, right, and if you give a very good video to us, very good documentation to us, so definitely we are going to post your things as well to iNeuron channel and all, and you will get a good social media presence, and it will be good for your career as well. You can share it in your resume, you can share it on LinkedIn and all, that you have done all those things. Okay, Sudhanshu, I think I have covered.
Yeah, thank you, Virat. So yeah, guys, so just try to participate excuse me in this challenge as much as possible. And I think you have a sufficient time, like a 40 days of time we have given you, so you can start exploring all those things. And this is basically a application based challenge. So we never try to launch any kind of a challenge where you just have to do some kind of a coding and then you will submit it like a Kaggle. So we always believe in building an end-to-end application, and based on same theme, so we have released our challenges. So where you will face all kind of a complexity that we used to face while building a small or big application, so that you will be able to complete the entire cycle. So yeah, and again, so there are lots of benefit, prizes is there, certificate is there, goodies is there, social media like this is there. So many things you will be able to get if you will try to participate in this one. So I'm assuming that all of you will participate in this challenge as much as possible, like many people last time has participated in that challenge. Yeah, so winner will be only 3, first, second and third, but the kind of reviews, the kind of feedback that we have received from the people, so they used to say that although I have not won the challenge, but I have learned a lot, many stacks, not only just one thing. Because when it comes to actual production grade solution, whether it's a small application or a big application, we all face challenges, we all face problems. So this is what I want you to face basically, so that when you will go and when you will be a part of industry, you will not face the same thing again. So you will be comfortable in doing any kind of a work. And with that, so we have launched this challenge. So I'm hoping that all of you will participate at least. And yes, almost like 10,000 plus people have registered. That's a good news. We can see that from our backend. Yeah, you have a competition with 10,000 people as of now. Just it's been 2 days since we have launched the challenges, so maybe it is going to increase by 20,000, 30,000. So which is normal, I would say, for the challenges that we used to launch. So you have a competition with a huge crowd. So just try to compete, try to build a best, I would say, a solution end-to-end everything, try to, and everything we have mentioned, data, problem statement, everything, summation links, everything is there in the portal itself. And I think we have already posted links in your chat box apart from that, so you will be able to get a proper notification and mail as well. So I think I have already sent you a mail. So you already have a mail. So just try to participate in the challenges and let me know. And let's see who is going to win this challenge. With that, so thank you so much, guys, for joining a class for today. So again, see you again in your next class, in your regular classes. So with that, thank you so much and have a good night to everyone.